Good day, everyone, and welcome to another edition of Division. That's right, today we're going to be using the standard algorithm to evaluate this. But as always, I'd like to point out this line. Did you know that that line literally means divided by? That's why we can actually use a fraction to represent this division problem. For example, we can write 3,569 up top divided by 6 on the bottom. Remember, this is referred to as a improper fraction. Why? Because the top is larger than the bottom. But we sometimes have to write this as a mixed number. And that's where this algorithm comes in. If we place the top on the inside and the bottom on the outside, we can come up with a mixed number. Observe. How many times will 6 go into 3? It won't go into 3, so we extend the line. How many times will 6 go into 35? We know that it'll go 5 full times without going over. 6 times 5 is in fact 30, and 30 from 35 is 5. Now, we bring down the number to the right, and we have 56. How many times will 6 go into 56? Well, I know that it'll go 9 times, because 9 times 6 is 54. Now I can subtract 54 from 56, which gives me 2. I bring down the number directly to the right, and I have 29. How many times will 6 go into 29? Well, it will go 4 full times. 6 times 4 is 24, and then 24 from 29 is going to be 5. Now I have 5 left over, so I have 594, remainder 5. Now, what does this tell me? Well, it tells me that 6 will go into that big number out there 594 full times. So I'm going to write that down because that's my whole number. It'll go 594 full times. But then what's left over? What's left over is the remainder of 5. I always put what's left over on top in the numerator position, and then the denominator just stays the same. So the denominator is going to be 6. So now we have 2 equivalent fractions, an improper fraction and a mixed number that represent the same value. And then we also, of course, have our remainder answer. We should write that down over here. We have 594, remainder 5. So that's 3 different ways we can come up with the answer to this division problem. Let's see if we can come up with a decimal. So what if we just erase this and we get rid of the remainder and we actually just kept going? So we've done everything. Now we're down to this. 29 minus 24 is 5. What happens if we keep going? Well, we ran out of numbers, but here's what we can do. We can actually put a decimal right there, and when we drop a decimal, we can drop a 0. And now we have 50. How many times will 6 go into 50? Well, let's see. I know that 6 times 9 is 54, so that won't work, so it's got to be 6 times 8. 6 times 8 is 48. I can now subtract 48 from 50, and I have 2 left over. And I can keep bringing down zeros as needed. A lot of times I'll go to like the thousandths place. Oh, look, it straightened it out for me. I'm going to bring down a 0, and I have a 20. How many times will 6 go into 20? Well, I know that it'll go 3 full times. 3 times 6 is 18, and then 18 from 20 is going to be 2. Oh, look, we got a 2 again. We're going to bring down a 0 again, which gives us another 20, which means it looks like the 3 is going to repeat. Now remember, if the 3 repeats on forever, we can just put a line over it and call it 3 repeating. Or in this case, the answer is 594, and 83, the 3 is repeating. 83, 3, 3, 3, 3, 3, 3, 3, but you get the whole point. There's 4 ways that you can come up with a quotient here. We have this, that, this, and that. I hope it was helpful to you. Good luck with whatever you're doing.